Hello everyone and welcome back to this video where we're going to focus now on polygons. So what is a polygon? Well, if you haven't encountered this before, just think of this as a geometric shape. So this could be a triangle, could be a square, could be a hexagon, whatever you want. But you can think of this as a collection of tuple points, okay? And the difference here is that it's actually going to form a closed shape. So the starting point, tuple coordinate, should also line up with the very last item on that list, which is going to be a tuple point coordinate which shares the same location. And that's going to close that whole shape so that you have a single geometry polygon. So, in Shapely, a polygon is defined as a constructor taking two positional parameters. So the first positional parameter is basically the ordered sequence of points that we see as being the exterior of that shape. And then we can actually also provide another unordered sequence, a ring-like sequences which are actually forming the interior boundaries, if we want, of a shape. So that would basically be like the holes. Think of the hole of a donut. Okay, we could create a shape that looks like the exterior of a donut, and then we could provide a second set of coordinates that would form a shape that would be the inside part of the donut. Okay, so that means we can create quite sophisticated polygon objects. So let's explore what that means within Shapely. So here we're able to basically go and get our polygon function. We're able to take our polygon function, we're able to give it a set of tuple coordinates in a list. Okay, and what that's doing is it's basically getting our polygon. Here I haven't actually closed out this list with a set of coordinates that basically provides the final end of the sequence as a closing point, but I'll just do it here like that so that you can kind of clearly see it. You don't always need it, but it's good to include it for kind of proper practice. But you can see that that's a triangle, okay, so it's a proper shape. It's a right-angled triangle. And we're able to check that that's a polygon using our geom_type function here. And then we're able to actually explore the fact that you can't have any less than 3 lines within a polygon in order to create a polygon, okay? If you just had 2 lines, you wouldn't be able to connect at all. So it's not actually a polygon, it's just a line string. You would need to have at least 3 lines in order to create some sort of object that can close so that it has an area and therefore becomes a polygon, becomes a shape. We're able to check this because unlike the other shapes that we explored, we're actually able to use the area function to get an area of our particular triangle here. And we're also able to explore the length of that particular object. We can also use our bounds function, so we can look at the bounds for this particular triangle that we've created, so the minimum x value, the minimum y value, the maximum x value, and the maximum y value. And then we're able to actually kind of create a new polygon altogether, one which has both the exterior, remember I was talking about the donut, the outside of the donut, and also an exterior set of coordinates which basically forms that interior. In this case, I think it's a square, but it could be the interior circle that's the hole in the donut, okay? So we're going to have our exterior coordinates here. So we've got this as a tuple list. You'll see we start and end on the same coordinates. And then we have the same for an interior set of coordinates. Again, these actually are just reversed to demonstrate that it doesn't matter which order you place these into the function. Then we're going to give it to our polygon function, give it the exterior, which is what we did in the previous example, and this time we're going to give it the interior examples. It actually needs to be in a list. We only have one interior polygon, so that's why we have this here forms one interior polygon, so it's a list of tuples, and then you need to put all of your interior polygons in a list again, because you might have multiple interiors, okay, so they need to go in the list. And that basically gives us this square here with another square rotated as a diamond basically on its side within this particular example, so that's quite neat. We can then access those coordinates, so we can go to my polygon 2, which is the polygon that we just created. We can specifically ask for the interiors, and this is going to give us a list which contains basically, in this case, a single shapely object. And we could have multiple, but here we just have one. So we can index into this using our zero indexing approach using the square brackets, as I've covered before, and that's going to give us just our single geometry object on the inside that we specified before. And then we can actually go to that, because it's a shapely object, and say, now give us the coordinates. And when we do that, it's going to give us a shapely coordinate sequence object, and then we can basically say, give me those coordinates as a list, and that's going to give us basically a list of those inner coordinates. Okay, so we've gone from putting coordinates into this polygon object and then extracting them. And then we can do the same with the actual exterior coordinates too. Okay, so we're able to place in the coordinates, make an object, and then extract them again. So it's really neat. So now what we're able to do is to basically go through this particular exercise. It's not going to be a long one. Essentially, you just need to create a polygon with the following tuples. So let me just go and get the code there. So here we go, we've managed to create our polygon object. Now we're able to get the area for that object, which is 9. We're able to get the bounds for that object as we required. And we're able to get the external coordinates. Let me just go and find this. Great, so we've managed to get those exterior coordinates and then list them from that shapely coordinate sequence. Secondly, we're able to make a new polygon. Okay, I've got some cheat code for this recorded, so I don't have to write it all out. But basically what we're doing is we're creating this exterior polygon, which is just exactly what I created in this previous instance. You'll see the actual sequence itself is the same. But then we have this interior set of coordinates, and what we do is we're going to give that polygon function our exterior area, and then we're going to give it our interior shape, only one this time in a list, and that should create this particular box. Okay. Now what we want to do is try to extract those. Okay, so what we're going to do this time, you're going to need to make sure that you essentially extract the exterior coordinates and make a new polygon in order to take the area. So we're going to go to my polygon 2, which is the one we just created. We're going to get the exterior, then get the coordinates, and we're going to list them, and then we're going to put this in a function which makes a new object. Okay, so here we go, we've got the coordinates, we then basically made a new polygon function, and then we got the area of that new polygon function. We're then able to do the same here. So again, you need to get the interior coordinates this time, so you need to make a new polygon. So I just go. So here's our shapely geometry object. Oops. So here's our coordinates. We're able to then give those coordinates to this polygon object and then get the area. Okay? Great, well thanks very much for tuning into this video. I hope it was constructive for you, and I'll see you all again in a later video where we're going to be focusing on GeoPandas. Thank you, goodbye.